Let us take an example on linear transformation. The question is, so that the transformation y1 is equal to 2x1 minus 2x2 minus x3, y2 is equal to minus 4x1 plus 5x2 plus 3x3, and y3 is equal to x1 minus x2 minus x3 is regular. We have to prove that this linear transformation here, y is called linear transformation of x because y1, y2, and y3, they are represented in terms of linear combinations of x1, x2, and x3. Therefore, y is called linear transformation of x1, x2, x3. If you want to show that this transformation is regular, then we have to show that determinant of A equal to 0. And determinant of A is nothing but the linear operator, means what are all the coefficients of x1, x2, x3 of the first equation, second equation, and third equation. So that coefficient matrix is called linear operator over here. If we are able to prove that determinant of A is not equal to 0, then we are able to see that, or we have found that the given transformation is regular. Now consider the determinant of linear operator. So how to get it? What is the first equation? 2 minus 2 and minus 3 minus 1. So this is the first 2 minus 2 minus 1. From the second equation, minus 4 plus 5 plus 3. Similarly, from the third equation, 1 minus 1 and minus 1. Now we want to simplify this determinant, or we want to find out the value of the determinant. If the determinant, the value of this determinant is not equal to 0, then we say that the transformation is regular. So let us try to simplify it. So 2 multiply by 5 into minus 1 minus 1 into 3. This minus of minus 2. If you want to find out its value, we have to leave this row and column. So minus 4 into minus 1. Let's look here, minus 4 into minus 1 minus 1 into 3. The third step is we have to leave this row and this column. Minus 1 into minus 4 into minus 1 and 1 into 5. Minus 5 into minus 1 is minus 5. Minus 1 into 3 is minus 3. Minus minus plus 2. Minus of minus 2 is plus 2. Minus 4 into minus 1 is plus 4. Minus 3. Minus 1 minus 4 into minus 1 is plus 4. And 1 into 5 is 5. If we simplify, minus 5 plus 3, 4 minus 3 is 1, and 4 minus 5 is minus 5. If we again simplify, minus 5 plus 3 is minus 2, 2 into 1 is 2, minus 1 into minus 1 is plus 1, minus 4 plus 3 is equal to minus 1. So clearly minus 1 is not equal to 0. Therefore, the given transformation is regular. So if you want to prove that any linear transformation is regular, we have to just prove that the determinant of the linear operator is not equal to 0. So this given transformation is a regular transformation. Thank you.